Number 7, let's begin how we always do, finding the vertex. We're going to use the formula x equals negative b over 2 times a, and we need to be able to use that formula correctly with parentheses. We're going to plug in the values of a and b, so let's identify those values. The a value is negative 1, the b value is negative 4, the c value is negative 6. So let's plug in the b value of negative 4, let's plug in the a value of negative 1, and the minus minus, it's like a negative times a negative, that becomes a positive, so you end up with a positive 4 over a negative 2, which means that the x value is negative 2. So we found the x value of our vertex. We still need the y value, so we need to take this negative 2 and plug it in right there and also right there into the x's. Now, just the way we did the formula, we plugged in with parentheses. We need to do the same exact thing over here when we plug into the x. So let's first rewrite it. Don't get lazy about this, guys. If you show all of your work, you're really going to reduce the likeliness of you making a mistake. So again, you rewrite the whole thing exactly the way it is, but instead of the x's, we put parentheses. And now we will be ready to plug in the x value of negative 2 right into those parentheses. So let's plug in those negative 2 values of x that we found with the formula. And then we're going to use Pemdas. Now, students always make mistakes right here. They always change the minus minus to plus plus. That's incorrect. The only reason we change minus minus to plus plus is because of the rule of multiplication that a negative times a negative is a positive. But before multiplying, according to the rules of Pemdas, the order of operations, we must do exponents first. So we really end up with a positive 4, and then you slap on that negative that's out in the front, so it's really a negative 4. And then we need to do the rest. So we have really a negative 4 times a negative 2. After exponents, we do multiplication. Negative 4 times negative 2. That becomes positive 8. And let's not forget about bringing down that minus 6 at the end. And now it's just addition and subtraction from left to right. Negative 4 plus 8, that is 4. 4 minus 6, that is negative 2. So right here we just found y equals. So all of this work was to find the y value of the vertex, which is also negative 2. So we have the most important point of this parabola, negative 2, negative 2. Let's graph that. Negative 2 on the x, negative 2 on the y. Let's put a dot right there at negative 2, negative 2. The very next thing to do, it should be like instant, right? Right after you draw your vertex, what do we draw? Axis of symmetry, that line right there, right through it. Okay. Now, notice that option or part B, you're going to get credit for writing the equation of the axis of symmetry. I mean, we need to draw it, but we also need to write the equation of the axis of symmetry, which is a vertical line, and we should know that any vertical line has x equals, and you just write the x value of the vertex, which is negative 2. Okay, so the next part of this question, it says to make an XY table or the pattern. You have to show some work. Either you do an XY table or you actually write down the pattern that we have memorized or that we should have memorized. I love using the pattern, especially when the a value is 1 or negative 1, because you don't have to modify the pattern. The pattern will be 1, 1, 2, 4, 3, 9. If you write that down on this location of your work on the quiz, you will get that point. Okay, so how do we use the pattern? You use it from the vertex. And even before beginning, like the pattern is 1 over 1, up or down, depending on if the parabola does open up or down. Now we know that the a value is negative, which means that it opens down. So instead of going 1 over 1 up, I'm going to go 1 over 1 down and put a dot right here. And then for my next pattern part, you go back to the vertex and you go 2 over 4 down. 1, 2, 3, 4, and put a dot right there. And if you wanted to use the last one, 3, 9, you go back to the vertex and you go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's off the graph. I'm not going to graph it. But I do need to map them over to the other side. So you get that dot right there and that dot right there. Please make sure that you actually graph these right. I see a lot of students that they put the points, sometimes they put them right on top of each other, which is incorrect. The axis of symmetry, 1 unit from here, 1 unit from there, right? 2 units, 2 units. That's how you know you have symmetry on both sides of it. And then we draw our parabola. And please try to make it look like a U-shaped curve. Don't make it like a V. Some students just draw like a V right there. That's incorrect as well. So that's your parabola. And let's continue to answer the rest of the parts of this question to get all the credit on tomorrow's quiz. Part D, what are the y-intercepts? Now this is something that we haven't done on parabolas, but we've done this in the past with lines. What is a y-intercept? It's where your line crosses the y-axis. So where's the y-axis? Here's the y-axis. Does that parabola cross up here? No. Does it cross at 0, 0? No, it crosses down here. So that location is 0, 1, 2, 3, 4, 5, 6. So what is the y-intercept? 0, -6. Or you could also say this, y-int is -6. You could just give the y value of where it crosses, right? Now, another point comes from just stating whether you have a maximum or minimum value. What do you guys say? Max. If you throw a ball up in the air, it goes in this path, it reaches a max height, and then it comes back down. So that is definitely a max value. Okay. I'm not sure if I'm going to ask for the specific max value or min value, because after all, it is the vertex itself. But if I did ask you for the max value, you could say the vertex itself, -2, -2. So you could say the location of that max value is -2, -2. Or you could say that the max value is the y value of -2 itself. Okay. So either one of these is good. Let me put them in a cloud because I'm still not even sure if I'm going to ask for the actual value, because after all, it is the same thing as a vertex. But I will be asking if you have a max or a min. This is definitely a max. Everybody should get F right, okay? Why? Because the domain of any parabola, is what? X equals all real numbers. Now, as you guys say that, I hear a couple of you just say the answer all real numbers. That's not, I can't give full credit for all real numbers. You have to say X equals all real numbers, okay? The range, that's the interesting one. The Y is what? Is it above a certain value or below a certain value? It's less than or equal to -2. If we understand that this parabola reaches a max height of -2 on the Y, that's the max height, and then it comes back down, then we should understand that the parabola is at -2 or below -2, right? So how do we write at -2 or below -2 with inequalities? Less than or equal to -2. Okay, so that's another point right there. Let's move on to the last one. This one's interesting. It says, part H, state the X-intercepts. So if the Y-intercept is where it crosses the Y-axis, what's your X-intercepts value? It's where it crosses the X-axis. As you can see, here's the X-axis. Where does it cross the X-axis? It crosses at 0? It crosses at -2? I mean, it passes through here? No, it doesn't, right? So where does it cross the X-axis? Nowhere. So what do we say? State the X-intercepts. We say none. Or you could say no real X-intercepts. Okay, now most of the time you will end up with parabolas that do cross the X-axis, especially on this worksheet. But actually, let me move this to the side and let me just draw a couple here. So get this, guys. It is possible to draw a parabola. You're graphing it. You find the vertex. You use a pattern. And you end up with a parabola that goes up and then it touches and then it comes back down. So right there, your X-intercept would be that value. Maybe that's the value of 2, let's say, right? Or sometimes you graph a parabola and it crosses 2 times, right? Right there and right there. Or sometimes you graph a parabola and it doesn't cross at all, right? So when they're asking for the X-intercepts, it's asking for the location on the X-axis of where the parabola crosses. It might cross twice, it might cross once, it might not cross the X-axis at all. And that's pretty much all there is to do on number 7. Might as well explain number 8. Number 8's interesting because the A value is 2, right? This A value is 2, which means we cannot use the pattern 1, 1, 2, 4, 3, 9 as it is. We would have to modify that pattern of 1, 1, 2, 4, 3, 9 by taking the outputs and multiplying them by that A value of 2. Okay, so let's understand that, guys. If your A value is 2, you're going to have to change that to a 2, change that to an 8, change that to an 18. If the A value were 3, you'd have to change the 1 to a 3, the 4 to a 12, and the 9 to a 27. Make sense? So whatever your A value is, that's how it's going to affect the outputs of your pattern. Anyway, let's go back to number 8, and let's start at the beginning, finding the vertex. X equals negative b over 2 times a. And of course, we're going to use parentheses. And we're plugging in the a value of 2. The b value, is the b value negative 5? No, the c value is negative 5. Remember this, ax squared plus bx plus c is your standard form. The number in front of the x squared is the a value. The number in front of the x is the b, but there is no x. There is no middle term. The c value is always a number without a variable. So the b value is 0. I'm plugging in 0. The a value is 2. So when I work this out, x equals negative 0 divided by 4. That's still 0. So the x value of the vertex is 0. If I want to find the y value, I'm simply going to rewrite that equation right here. Y equals 2x squared minus 5. Notice that I wrote parentheses instead of x. That way I could easily and safely plug in that x value of 0 and work this out. 0 squared is 0, so you really have 2 times 0 minus 5. What's your y value going to be? Negative 5. So your y value of your vertex is negative 5. And notice that I showed my work here, guys. You need to show your work to get credit. Okay. Let's graph that most important point at 0, negative 5. So 0 on the x, negative 5 on the y. Here it is. After that, you draw your axis of symmetry right through it. And now we obviously need some points. Okay, we need some points. So even before the points, it does say state the axis of symmetry. So what is the axis of symmetry? X equals, you have to write x equals because that produces a vertical line. X equals what? X equals the x value of your vertex, okay, which is 0. Okay, so remember, if you want your vertical line, first of all, if you want a line that's vertical, it has to be x equals, and the number that belongs here is the value that it crosses through, which is the x value of 0. Okay, if it were cross over here, it'd be the x value of 6. If it were cross right here, it'd be the x value of 5, the line x equals 5. Does that make sense? Okay, and just as a reminder, the axis of symmetry will always be the x value of your vertex. So simply x equals 0. If you'd have a 1 right there, it'd be x equals 1 because it has to pass through your vertex. Okay, so part C, you want to either use the pattern 1, 1, 2, 4, 3, 9, but you can't use that pattern because the a value is 2, which means you have to modify it by 2. So if I actually changed my second number, if I go 1 times 2, I'll get a 2. If I go 4 times 2, I'll get an 8. If I go 9 times 2, I'll get an 18. That's my new pattern. That's the pattern that I could use. I can't use 1, 1, 2, 4, 3, 9. I have to modify it. Now, if that kind of confuses you, all right, then just go ahead and go to an XY table instead, right? And you could plug in, well, you wouldn't plug in 0 because we already plugged in 0 for the vertex and we got out a negative 5. But you could plug in a 1 and a 2, and you do all that math, and you'll be able to get 2 more coordinates, and then you can map them over to the other side. So let me go with the pattern. Whoa, that was ugly. Let me go with this pattern first. 1, 2, 2, 8, 3, 18. So from the vertex, I need to know if this thing opens up or down. What do you guys say? Up, because the a value is positive 2. So I'm going to go 1 to the side, 2 up. So 1 to the side, 2 up. I'm going to put a dot right here. And then I'm going to go back to the vertex, and I'm going to do 2, 8. So 2 to the side, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot right here. And if I go back to the vertex and try 318, that's going to be 3 18s way off the graph, so I'm not going to bother with that. However, I am going to map them over to the other side right here and here. Now always double check, make sure that you actually got the equal distance from the axis of symmetry. 2 units, 2 units, 1 unit, 1 unit, right? So now we're able to graph the parabola. Even though it's narrow, try to make that little curve down here on the vertex. so it doesn't look like a total V. So we've graphed it. Let's say you didn't want to use the pattern. Then you could have plugged in the number 1 right in here. So let's think about that. Plugging in 1. 1 squared is 1. 2 times 1 is 2. 2 minus 5 is negative 3. So for the input 1, you get the output negative 3. Okay? Now if you were to graph 1, negative 3, here's the vertex. And if you go 1, negative 1, 2, 3, I mean the origin, I'm sorry, not vertex. You go 1, 1, 2, 3, get to that red dot right there. And if you plugged in a 2, let's do that. Plug in a 2 right here. 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. So for the input 2, we get the output 3. And this is a coordinate. And if we were to graph that coordinate, here's the origin. 1, 2, 1, 2, 3, we get this other red dot. So these two coordinates with an XY table gave us this dot down here and this dot up here. Map them over to the other side, you end up with the same exact parabola. So I've explained both methods. It's up to you if you want to do the XY table or if you want to do the modified pattern. I like the modified pattern. You want to go with the XY table, go for it. It's totally up to you. You do not have to do both. You're not going to get more points if you do both, right? So pick one or the other. And then let's continue answering the rest of these. So what is our y-intercept of this parabola? In other words, where does this parabola cross the y-axis? Right here at this value. So you could say that the y-intercept is negative 5, or you could write it as a coordinate 0, negative 5. Totally up to you. Okay? Now, max or min, what do you guys say? There's a min value. Obviously, it's going down, goes down, then all of a sudden it reaches the lowest point, the minimum point, then it goes back up. So that's a min value. If you did want to state what that min value was, you could say y equals negative 5, because that's the lowest value. Or you could write the actual vertex itself, 0, negative 5. Either one of those is totally fine. I'm not sure if I'm going to ask that, because it's the same thing as a vertex, right? The domain value, it's like a free point. X equals what? All real numbers. How about the range? Y is what? Above a certain value or below a certain value? That's right. Greater than or equal to negative 5. Remember, this whole parabola, it touches the lowest point's negative 5, and the whole parabola is above negative 5. It's not below negative 5. It's above negative 5. So y is greater than or equal to negative 5 because it actually does touch negative 5. And now for the final one, H, it says state the X-intercepts, and notice it says approximate if necessary. So sometimes we're going to get nice values like, oh, it crosses at negative 2 and positive 2, but right here they're not nice values. So what we want to do is zoom in and give an approximation. So where do you guys, here's the origin 0, 0. So does it cross at negative 1 on the X? Does it cross right here at negative 1? Does it cross at negative 2? No, so what would your approximation be right there? Negative 1.5, that's good, or maybe negative 1.6, whatever. Anything in that ballpark is full credit for me. So let's write down X-intercept, X-int, and we're going to say about, we're going to put the little squiggly equal sign, negative 1.5, we said. How about the other one? So and, let me write down and, because there's another one. Let's look at it. What do you guys say this one is? Here's the origin, 1, 2, so what? 1.5, okay. So negative 1.5 and positive 1.5. Like I said, some of these you're going to end up with nice answers. But some of these we're going to give an approximation as a decimal, okay? And that's about it, guys. You guys have the rest of the worksheet to do. If you guys get stuck in class, you could raise your hand. Or if you're at home, there's other videos, 2 previous videos explaining every single question on this 2-sided worksheet. And the quiz is coming pretty much straight from one of our worksheets. Good luck.